So we're going to keep going through the chapter 1 and 2 tests here, starting from question 13. And this one was a little bit tricky because it asks us to apply that normal distribution knowledge. So it says Ruth sells eggs, and from past experience, Ruth knows that the mean weight of the eggs that she sells is 56 grams. So X bar is 56. And it says then that 2% of the eggs that she sells is greater than 65 grams. So if we first of all get started, we need to draw this normal distribution. So we can draw the curve, and I know that the mean here is 56, and I've got some standard deviations above and some standard deviations below. Now, the rest of the question asks us to find the standard deviation of the weights of these eggs, and we don't know what they are. But what we do know is 2.5% of the eggs have a weight greater than 65 grams. And if we link that to the table that we have of the normal distribution, we know that the 95% rule sits at 2 standard deviations, and it has tails of 2.5% either side. So what we're saying is this part here is that 2.5% that is then greater than 65 grams as that standard deviation at the bottom. Now, what we need to work out then is how big is the distance between this and the standard deviation in the middle that we don't know, and then that same distance gets added to give us 65. There are two ways that we can do this. The easiest way for us to find the standard deviation is we could do 65 minus 56 and divide that by 2, because we know that we've added on the standard deviation 2 times to get from 56 to 65. So if I do that, 65 minus 56 over 2, that gives me 4.5 grams. And so my answer there would be E. Another way that I could do this then, since I know it's 2 standard deviations, is I could check all of these and check if I do 56 plus 2 lots of whatever the number is, do I get 65? And so if I do 56 plus 2.5 plus 2.5, which is the first one there, I end up with 61. So that's obviously not the answer. Again, if I repeat that for the 3 grams, so 56 plus 3 plus 3, I end up with 62. So again, that's not the answer. So you could work through each one like that in a bit of a trial and error, or you could do the little equation that I solved to begin with. Question 14 here, it's got parallel box plots below summarise the distribution of population density in people per square kilometre for 27 inner suburbs and 23 outer suburbs of a large city, and it wants to know which of the following statements is not true. So we do need to work through each statement here. First of all, A, more than 50% of the outer suburbs have population densities below 2,000 people per square kilometre. So if we look at this, outer suburbs, and I like to take the 2,000 from the scale, and if I mark it up here, we know that each part of the box plot, so the whisker and then the box, represents 25% of the data, and so where this red line is sitting, we can see we've got 25%, 25%, and then a bit more. So yes, more than 25% sit below 2,000, so that's true. B, more than 75% of the inner suburbs have population densities below 6,000. So again, if I take the 6,000 here and go up, I've got 25%, 25, 25, that is 75 plus a little bit. So yes, this is also true that more than 75% of inner suburbs have densities below 6,000 people per square kilometre. C, population densities are more variable in the outer suburbs than in the inner suburbs. Remember, if we're talking about variability, we're talking about the spread. And so that's us thinking about the range, or the IQR. And if we look at this, we can see that the inner suburbs plot is longer than the outer suburbs, and so is the box part in the middle. So actually, inner suburbs are more variable. Now, this said that outer suburbs are more variable, which is not true. So yes, C will be our answer, but we should just check the others to make sure we haven't made a mistake. The median population density of the inner suburbs is approximately 4,400 people per square kilometre. So I'm going to go from the median, which we know is this centre line, and if I try and draw this down nice and straight, then yes, it is approximately 4,400, so we'll get rid of that. And population densities are on average higher in the inner suburbs than in the outer suburbs. Well, yes, we can conclude that true if we compare specifically to the medians, the two green lines. We can see that median is higher for the inner suburbs, so C was definitely our answer there. Question 15, STEM plot below shows the average number of decayed teeth in 12-year-old children from 31 countries. Key thing here is interpreting the key, because 0 dash line represents 0.2. So that is where lots of people made some mistakes. Based on the plot, the distribution of the average number of decayed teeth is best described as, and first of all, we've got to talk about the shape of the distribution. If you're watching this, I recommend you turn your head to the right-hand side, and if you do that, you can treat each part of the STEM plot like it's bar of the histogram, I guess, and you can see that it sort of does that shape, which we know we would call positively skewed. So that straight away allows me to get rid of A, C, and D. And in actual fact now, I should just be able to pick E as the answer without doing any of the work, because the median numbers and the range numbers were the same for everything, but the difference between B and C is interpreting that key and knowing that numbers have a decimal point in it. So therefore the answer is going to be E. Question 16 and 17, look at this dot plot. It shows the difference in travel time between the morning peak and evening peak travel times for the same journey on 25 days. And question 16 says the percentage of days when there was 5 minutes difference in travel time is. So if we first of all look at this 5 minutes travel time, it's talking about this here, we can see that we've got 1, 2, 3, 4, 5 dots. Remember, we want a percentage, so we've got 5 over 25 times 100, and that does give us 20%, so my answer is C. Question 17 then wants the median difference in travel time, which means we need the middle number. Since there are 25 pieces of data, that means we want the 13th item. So I'm just going to count from left to right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to circle that. I do like to count next to it to make sure I still get another 12 to know I haven't made a mistake. So if I keep counting, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this one here lines up with being 3. So because the dots there are sitting on each of the lines, so it is a median difference of 3 minutes. Question 18, another normal distribution here, says the time taken to travel between two regional cities is approximately normal distributed with a mean of 70 and a standard deviation of 2. So there's my curve, and there's 70 and 3 standard deviations above, 3 standard deviations below. It wants the percentage of travel times that are between 66 and 72. So I do need to fill in this standard deviations. To go up here, I'm adding 2, so this will be 72, 74, 76, and subtracting standard deviations, this goes 68, 66, 64, and between 66 and 72 means we're talking about here to here. Now, this is when it would be handy to use that image that we drew where we knew these bits here contain 34% each, and this bit here contains 13.5%. And if I then add them all together, so 13.5 plus 34 plus 34, I get 81.5%. So the answer would be D. And I really recommend, if you don't have that image in your reference book, you do fill that in and fill in what all of the various percentages would be for each section. Question 19, I think, is the hardest question on here. It says that a class of 25 children in year 5, 15 girls and 10 boys sat for a maths test, and it gives us the mean score for the 15 girls being 28.5 and the mean score for the 10 boys. Now, a common mistake was to add those two means together and divide it by 2, which gives 27, but that answer is incorrect because there are more girls than there are boys, so that actually doesn't give us an even representation of the class. What we do need to do is actually look at the value for the girls and the boys first of all, and before I do that, I hope you agree with me that if we're finding an average, it's coming from the total of all the scores and dividing it by the number of scores. So for the girls, their average of 28.5 comes from taking the total score for the girls and then dividing that by 15. So I can use the solve function in my calculator or undo this algebraically. If I multiply both sides by 15, the total score here is 28.5 multiplied by 15. Sorry about my pen, it's just having a moment. So 28.5 times 15 gives us 427.5. Now, if I do the same thing for the boys, their average of 25.5 comes from taking the total of all their scores and dividing it by 10. So the total for the boys comes from then doing 25.5 times by 10, and that will be 255. Now that I know those two totals, I can actually find the average for the class by adding the 427.5 and the 255 and then dividing that by 25, because this gives me the total for the 15 girls and the total for the 10 boys. So if I do 427.5 plus 255 and I then divide that by 25, I get 27.3. So my answer there is D. Finally, question 20, just another question with the log scale for us. Most of us did quite well at this one, but we just struggled with actually then reading part of the question. So it shows the log area with area in square kilometres of 17 islands, and it gives us the frequency, and it wants to know the median area of these islands in square kilometres. Now, if there's 17, the median is going to be the 9th piece of data. So look at the frequency first of all. There's 1, 3, 4, 2, 4, and 3. And then I want to count and find where the 9th part is. So 1 plus 3 gives me 4. 4 plus 4 is 8. So the median is in here. It means the median is between 3 and 4. And if we go back and read the question note, it says the median of these areas of the islands in square kilometres. So it wants me to undo the log. So lots of us said B, which is actually incorrect. We need to work out what 3 and 4 represent as logs. So remember, for me to rewrite this, the 3 means I'm adding 3 zeros after the 1, and the 4 means I'm adding 4 zeros after the 1. So the log 10(3) represents an area of 1,000 square kilometres, and 4 represents 10,000 square kilometres. So my answer here is actually D, 1,000 and 10,000. That's the end of the questions. I hope this was helpful for you. Please come speak to me if you have any more questions, and I'm happy to help if you need. Thank you.